At 3:09 UTC on December 12, 2025, something just slammed into the moon. And this time, it wasn't discovered hours later in archived footage or after heavy processing. It happened live, unfolding in real time on an astronomer's screen. A sudden, sharp flash appeared on the moon's night side, bright enough to stand out clearly against the darkness. It lasted only a fraction of a second, but that was enough. Cameras were already rolling. The timing was precise, and the location was clear. This wasn't a theory or a simulation. It was a real collision recorded as it happened. The flash was detected at the Armagh Observatory and Planetarium in Northern Ireland using the Armagh Robotic Telescope. The observation was made by PhD student Andrew Marshall-Lee, who was actively monitoring the moon at the time. What makes this event unusual is not just that it was recorded, but that it was seen live. Lunar impact flashes are normally found later, after astronomers comb through hours of high-speed footage frame by frame. In this case, the burst happened directly in front of the observer. Marshall-Lee said that seeing it unfold in real time was something he might never experience again, even after years of observation. That reaction alone hints at how rare this kind of moment actually is. Based on the brightness and duration of the flash, astronomers believe the object was extremely small, possibly no larger than a golf ball. But size is misleading in space. Objects moving through the inner solar system can strike the moon at tens of kilometers per second. At those speeds, even a pebble carries enormous kinetic energy. When it impacts the lunar surface, that energy is instantly converted into heat and light, producing a visible flash. There is no atmosphere on the moon to slow these objects down. No weather, no shielding. When something hits, it hits hard and keenly. The result is a brief white flare, often lasting less than a second, and then nothing. No sound, no lingering glow, just a scar added to the moon's already cratered surface. The impact occurred just hours before the peak of the Geminid meteor shower on December 13. That timing is important. The Geminids originate from the asteroid 3200 Phaethon, a strange object that behaves partly like an asteroid and partly like a comet. Each December, Earth and the Moon pass through debris left behind by this object. During major meteor showers, the rate of impacts on the Moon increases. Astronomers know this, and many lunar monitoring programs schedule their observations specifically around these windows. According to Armagh Observatory researchers, lunar impact flashes are rare overall, but they become more likely during events like the Geminids. That makes this meteoroid a strong candidate for being part of that same debris stream. If impacts like this happen, why don't we see them all the time? The answer is visibility and patience. These flashes only occur on the moon's night side. They last fractions of a second, and they're faint enough that you need fast, sensitive cameras attached to telescopes roughly 20 centimeters in diameter or larger. Even then, astronomers may monitor the moon for dozens of hours without seeing anything at all. Catching one live requires the right timing, the right equipment, and a fair amount of luck. That's why this particular event stands out. It wasn't just recorded, it was witnessed as it happened. There's another reason scientists care about these flashes. They tell us what Earth doesn't experience. The moon acts as a natural shield, absorbing meteoroids that might otherwise pass near or toward Earth. Its surface is a long-term record of impacts that never reached us. By measuring lunar flashes, researchers can estimate how often small objects are hitting the Earth-Moon system as a whole. This helps refine models of meteoroid populations and impact risks. This wasn't the first lunar impact recorded in recent months. In November, at least 2 other flashes were captured by amateur astronomers and shared publicly. Those events are now being analyzed alongside this December impact. Together, they suggest that the moon may have been passing through a slightly denser region of debris than usual. Whether that's linked entirely to the Geminids or something more complex is still an open question. For now, teams are comparing trajectories, brightness curves, and timing to see if a clearer pattern emerges. Researchers will continue analyzing the footage frame by frame to estimate the impact energy and refine the size of the object. If possible, they may even identify the fresh crater left behind, though that's far from guaranteed. More importantly, lunar monitoring programs will remain active through the rest of the meteor shower season. If another flash appears, it could help confirm the source and improve impact models. For something so small, this event is contributing to a much larger understanding of how space around Earth really behaves. If you enjoy real-time space discoveries like this, take a moment to subscribe. It helps more than you think. The moon is often seen as quiet and unchanging. Events like this remind us that it's constantly interacting with its environment, silently absorbing impacts that would otherwise go unnoticed. A tiny object, a fraction of a second, and a brief flash of light. But behind it is a story about debris streams, planetary shielding, and how closely we're actually watching the sky. And this time, we didn't just catch it later. We saw it live. What do you think this object was? A pure Geminid debris, or something else, passing through? Let me know in the comments below, and thanks for watching.